Push That Rock here with Simpson Math, announcing a bonus opportunity for you, lucky you who watched all the videos. Good job. This is a logarithmic application exercise. So that means you have to show all your work and explain how you got to the answer, but also write a sentence that explains the context of the answer. Remember to do that. And this is due the class period after our Thanksgiving break. So you have a little time to get it done. But that very first class period after Thanksgiving break, have this with whatever other daily points you have ready for that day to submit, okay? All right, I'm going to help you just a little bit by making sure we understand the context of this problem and making sure that you can read it. So let's blow it up a little and bring it over so we can read it together. And for all the people that have trouble with my handwriting, which I know is not the best, actually it's fine, but a lot of people have trouble reading, I'll read it to you. So entomologists, those are people that study bugs, model P, the approximate percent of emerging mayflies eaten by predators, where the percent is the actual percent, not the fraction or decimal. So if we're talking about 75%, P is 75. Don't change it to 75 hundredths. Don't change it to 0.75. Just leave it as 75 if we're talking about 75%. That's what this phrase, where the percent is the actual percent, not the fraction or decimal, means. Okay, they modeled this percent of emerging mayflies eaten by predators using this model right here. There's the function. When we use the word model, that means function. Okay, so here's the function, and it models that percent. Now, in this model, the input N, the letter N, which is right there is the input, represents the number of mayflies that are emerging. Okay, so the question is, how many mayflies must emerge for roughly 50% to not be eaten? That is roughly percent. If they're not eaten, then they survive. So how many mayflies must emerge for roughly 50% to survive? Happy Thanksgiving.